Hey, folks, welcome to the Oracle Autonomous Database Learning Lounge. I'm Marcos Anasivia, Product Manager for Autonomous Database. And today we're going to have a very, very cool session on graph, right? So, how to add context to your data using graph technologies, right? So, we're going to see, a lot of great things that are related to graph. So, we're going to have Melliyal Annamalai. She's a distinguished product manager. And also, we're going to have Jason Duncan-Wilson. He's a senior director, right, of product Incubator at Oracle, and he's going to be talking. Both are going to be talking about graph technologies, right? So basically, how actually these graph technologies generate these knowledge graphs. These are also known as ontologies, right? So these kind of technologies allow you to understand better your data, and you can put a business context to connections that you previously did not understand. And in autonomous database, we do have a way to manage. We can store those ontologies and we can query them. So you're going to see all of these kind of technologies, and then Jason is going to talk about Oracle Energy and Water and how they use that to basically better connect data between the utility companies, right? So throughout the session, we're going to have an open Q&A. So at any time, if you guys have any questions, please type them in the Q&A box of Zoom. We are going to distribute some links to you guys via chat, so you can check that, all right? And basically, these are some of the important links that we would like you guys to remember. I'm going to just share with you right now in Zoom. So basically, we have our Get Started link. That's the main page for Autonomous Database. We are in LinkedIn and X. You can ask your questions as well in Stack Overflow. But also, I'd like to point you guys to the Oracle Slack channel, right? So we have an Oracle Developers Slack channel that is external. So this Slack channel, if you guys just join with the link there or the QR that I'm showing, you can actually join with your normal email. You get in there and then search for Oracle Autonomous Database. You're going to find that channel. In that channel, we have not only announcements, right, of things that are coming, but we allow you to ask your questions there, and we have product managers looking that as well, right? So we can answer your questions. Again, really appreciate you guys joining today. Before I pass the ball to Melly and Jason, just want to let you know that tomorrow I am doing a special, session on the Oracle Modern Data Platform test drive series. This is going to be a live demo of everything from creating an autonomous from scratch to loading data to it, to using machine learning and AutoML UI on top of it, to then exploring that data in OAC, in Oracle Analytics Cloud. So that's just for your information, okay? So here's a link as well. I'll put the link in the chat, right? So right now, I'm going to stop sharing and let Melly, I think you're first, right? You're going to share your screen first?
Yes.
Okay, so thank you for joining us. Really appreciate it, and take it away.
Thank you very much, Marcos, and thank you for those polls, which were really useful to kind of, like I said, help us know where to start. So hello, everyone. Thank you for joining us. It's great to be here. I apologize for my raspy voice. I'm recovering from a throat infection, but I'm only planning on talking for a few minutes, and then I'll be handing off to Jason, who'll be talking about the really exciting stuff about how they're using knowledge graphs for building out their service. So I will talk about what features we have for knowledge graphs in Autonomous Database. And then, like I said, Jason will talk about the exciting stuff. So as you know, all data has context. Some of it can be gleaned from the schema, like the table name, the columns, but just to understand what something means. Like I have a name column in my table, like to understand what that means. How do I understand what that means? Because that could be the name of a person, the name of a place, or the name of a product. And if I know it's the name of a person, it could be the name of a customer, in which case the table is expected to have information like history on the things this customer has bought. Or it could be the name of an employee, in which case the table is expected to have things like the role in the company, and so on. So there's a lot of context that goes with every single piece of data that you work with. And this context includes relationships between data. Like in this case, you have customer, employee, company. These are some of the things that we were talking about. A customer could have bought a product produced by a company that an employee works at, and so on. So knowledge graphs are really good at capturing this kind of context and relationships between different entities so that applications can use them to basically understand more about the intrinsic meaning of data. So how can knowledge graphs do this in Autonomous Database? So we have comprehensive support for knowledge graphs in Autonomous Database. Several years ago, the World Wide Web Consortium came up with standards and formal semantics for how information about a domain can be represented. Like if you take the biomedical domain, different drugs, how they interact and so on, you can capture information from experts and represent that as a knowledge graph, also known as an ontology. And that ontology can be used to provide context in applications that use this information. So in Autonomous Database, we have comprehensive support for these World Wide Web Consortium standards. And I'll just have a very high-level example to conceptually explain what we mean, what these standards do for us. So here you have, for example, here a person who is a category, and a customer and employee are types of person. So they're subcategories or subclasses. And a person has these properties, let's say name and social security number. Every person will have a name and a social security number. And all this can be represented using the standard ways, the standard defined by the W3C. And once you have this information, the standard also helps you derive new information. So since a person has a name and a customer is a type of person, then it follows that the customer also must have a name. So you can automate getting new information from curated information provided by experts. So you can build up knowledge about a domain to create what I said, ontology, which captures information about a domain. There is information from third parties like this GeoNames ontology. There's ontology about weather concepts. DBpedia data is accessible as an ontology, or you can have your own ontology. If you want to integrate two data sources and you want to understand how, I want to explain how the concepts can be related to each other, then you define your own ontology. So, and using the W3C standards for doing that, the knowledge graph standards for doing that, helps consumption of these things programmatically. So the key thing, the key innovation that we have that's available in Autonomous Databases, the ability to query these knowledge graphs from within a SQL query. So the standard also includes the ability to query knowledge graphs. There's a particular syntax for doing so that you can see in red here. And you can embed such a query within a SQL query. So any SQL query can consult an ontology to get more context about a particular data element. And that is one of the really cool things we have as part of Autonomous Database. So you can store, manage, query, and infer that get new information for any size knowledge graph. We have comprehensive support for all the standards I was just talking about. And we also have integration with some knowledge graph tools and also SQL tools. You can use SQL Developer, for instance, to work with knowledge graphs. And Oracle innovation, as I was saying, is the ability to query knowledge graphs from within SQL so that you can use the right tool for the right job. You can use SQL syntax for all the SQL stuff you need to do. and use knowledge graph syntax when you want to query knowledge graphs. And of course, all of this is available in Autonomous Database, specifically in Graph Studio, which is part of the fully managed Autonomous Database service. And then the Graph Studio notebook can help you get started easily with knowledge graphs. There are many different use cases for knowledge graphs. I think I'm going to transfer over to Jason at this point.
Thank you, Melly. And hey, Jason, how are you? So yeah, just take it over. You can start sharing your screen, and thank you for coming.
Sounds good. Thanks. Thanks, Melly. My team is building a new service on OCI, and we're taking advantage of all the stuff that Melly just went through. So I'm going to talk through how we're leveraging a lot of the great graph capabilities and JSON capabilities of Autonomous Database that merge with some of the relational data, and then I'll show some great demos and examples. So first, our service is really focused on industry data. We're starting with the energy and water industry, and our goal is to take data from a lot of the utility sources that exist, get them to all the targets, both internal for utilities and external, and we'll be moving to other industries after that, like construction and engineering. But in order to achieve that, the first question is really, how do we get all this data coming from different systems to make sense together, to have that intrinsic meaning that joins together? So I'm going to go through a few real-life examples of enterprise system data. This is data from the Department of Energy. We got EV charging stations. And these status codes are what you'd expect in kind of source systems. It's what you typically see in transactional systems. So they use short codes, different things that you might not be able to guess them right away. So when I've asked people before, can you take a guess at what E means? They often guess maybe electrified or something like that. Surprisingly enough, that's not at all what it means. E means available, P means planned, T means temporarily available for these status codes coming from this source data for charging stations. Another example is equipment for some of the utility systems that we work with. This is an ID type. So again, probably can't guess every single one of these values. Maybe would have been able to guess serial number, but probably not the other two. And then one last example is even zip codes. So you look at these and you think, okay, these are obvious what these are for these franchise locations as the original data set. But actually, every single one of these zip codes is not a US zip code, which might be everybody's guess. These are actually Brazilian zip codes. So these are just small examples of why using a knowledge graph and using an ontology is necessary when you're getting data from lots of different sources and trying to make it make sense together. So my team, very much leaned into using Autonomous Database for this. We're able to leverage relational data, since that's what is coming from most of the sources, standardize the data, use the graph capabilities in Autonomous Database, as well as the JSON capabilities, so that whether it's row-based, network-based, hierarchical data, we're able to get it in every form we need to make sense out of it. I'll show you some examples of that here in a minute with these demos. So just a big view of what we're focused on. We got data coming from enterprise systems for utilities and other companies. We also have other data sources, like I mentioned, the Department of Energy, other public data sources like census. We bring that into Autonomous Database, and we're leveraging ontology, really the nouns and verbs of an industry, to make sense of how to connect that meaning. And as a result, you can see kind of data in the bottom left from these enterprise systems, very code-based, very transactional-based. We're actually able to produce great language output, which I'll show more of in a minute, that actually is great for feeding generative AI, but also great for just bringing that meaning together across systems. We're doing this with different layers of intelligence. So I'll show you some queries of the ontology here in a minute, but you can actually stack lots of different graphs, lots of different ontologies together in a single Autonomous Database to come to these answers. Okay, so just a quick view of what this looks like for the energy and water industry that we're focused on at first. So like most industries, each industry has their little domain pockets of understanding of data. You might even think of each of these colors as like a particular source system for that domain. The first thing we need to do is really bring it together in the center and make things connect that should connect across different systems. And once we do that, and connect the meaning of everything, we're actually able to start branching out for the industry. So very much for the energy space, it's becoming a different world where it used to just be energy was delivered in one direction by utilities, but now it's really a two-way grid where electric vehicles, battery storage systems, everything you see on here is starting to make it a more complex world. So it was a necessary point for us to go make sense out of this data with a knowledge graph. Quick overview of some key features we're leveraging in Autonomous Database. So Melly mentioned the semantic match queries that are in Autonomous Database. I'll show some examples of this. We're leveraging this heavily to flatten really the results of a knowledge graph query so that it's able to be leveraged in standard SQL. We're also connecting graphs virtually. So we'll bring in data from 4 or 5 different sources, but knit those together in a single virtual graph. And the other thing we're leveraging too in Autonomous Database is the geocoding that's natively in the database. And I'll show a little bit of that as well. Okay, time to get into the demos. So first, I'd like to just really focus on the data. And I'm going to do a flyby of taking data from raw in relational form to standardized in relational form into a graph, and then ultimately the language output for that as well. And I'll do a flyby of this, but then I'll go into it in a lot more detail to show you some of the things behind it. So we've got a couple different systems, and this is showing you database actions for Autonomous Database. We're bringing in data from multiple sources. So this is data coming from a customer system, again, super transactional, super broken out. This is a person record from a utility customer system. So it's many tables, as you'd expect, in kind of third normal form, coming in raw form. And we're taking that all into a staging area as part of Autonomous Database. Some examples of bringing in third normal form data from a grid system for utilities. This is a different source of data, again, very transactional in nature, lots of codes, lots of things that you might be able to squint and guess what it is, but in some cases won't be able to, just because it's very code based. So first thing we do in this service is standardize it in terms of just a relational form. So again, this is looking at a standardized form of that same person data, a lot more understandable. So it's starting to come into focus. Just a few more examples of standardizing that data in relational form. Again, this is before the graph. So standardizing it to different codes and things that make sense across groups. Same with the grid system that I just showed, standardizing these transformers that are coming in for utilities. And as a result, we're able to also standardize data coming from public sources like electric vehicle charging locations. So in a minute, I'll show heavily Autonomous Database, and then I'll go over to Oracle Analytics Cloud and show you some of the results we get from this. But we're bringing in every public EV charging station from the Department of Energy into this as well. So it's just a flyby of what you're used to in a database, like relational form data. First started as raw, then went to standardized. Next, I want to show you the geocoding service, the results of it in Autonomous Database. So there is now natively built into Autonomous Database a geocoding service that we're able to take advantage of. My team is. So what we've done here is we've actually run an audit on all the addresses coming into Autonomous Database. And as you can see here, I'm going to open this up a little bit. We've got this match code that comes back. So all these ones are actually like, saying, okay, all these addresses look great. When I get to the match code of 2, so you get a different match code back from the API, the geocoding API, you can see here that we've got addresses coming from this particular source, this customer system, that actually are slightly wrong. And Autonomous Database is helping us figure that out. So this one in this case is Boulevard, it should be Street. This one's actually missing Avenue when it should have Avenue. Again, there were a bunch of them that looked good, but a bunch of them that are slightly wrong. So we're doing that kind of address validation as data is coming in. It's just one example of validating data with the capabilities built right into Autonomous Database. Once we've validated the data, then what I'm going to show you real quick is an example of one of those semantic match views. So a goal that we've had for the utility industry is to really join person data over to the electrical grid to get that view of, all right, you got a customer, they're at a household, and they're being served by this particular equipment and this particular line on the electricity grid. So this result here is able to show us that. So I'm going to highlight one row here. And this is a customer, and it's joining all the way over from, across, 13, 14 different records coming from 4 different sources, all into Autonomous Database and in one graph. And I'll show you this graph query here in a minute. But we're able to see a particular person, their first and last name, some of their attributes of their service, but then also the transformer they're served by, the circuit, the substation, all the way up the grid, which was a key result we wanted to get out of a knowledge graph. And then as we go further into the knowledge graph capabilities, we also are able to produce language-like output for these same records. So you saw data getting standardized for a person. This is an example of actually spitting the data in language-like form out of Autonomous Database. I'll also show those electric vehicle charging locations I was talking about. So let me pull this open. This is an example. I'll show, let me get into this in more detail for you all. So this is an example of spitting out true language prepared output from the knowledge graph directly in Autonomous Database. So let me go into a little more detail of how I got here. So we went raw, standardized, all in relational. Then we went to semantic match queries as well as these language output queries. I'm going to show you the more detail of how I got here. So what I want to do is I want to pull over, and I mainly want to show you this just so you understand, you got the web interface here for Autonomous Database. You can also use SQL Developer for a lot of this as well. So the same queries I was executing in the web interface, I can also do traditionally in a SQL Developer that people may be more accustomed to. Same query that I was showing person to electric grid. So I want to show some of the knowledge graph ontology and some of the combined knowledge graphs in here. So regular models are the knowledge graphs we're actually building out within Autonomous Database. The virtual models are where we're actually bringing together multiple knowledge graphs into one queryable state. So I'm going to do some really simple queries here first. So let me go I've got a query I'm going to pull in. This is a Sparkle query. And this is just going to show you the different concepts that we have in this energy and water ontology. So, things from wind turbines to water meters to service types for utilities, different ways that they're built. Lots of the different concepts that are specific to the energy and water industry, all stored in this ontology knowledge graph within Autonomous Database. That's just to give you a flavor of what's in the ontology. So lots of concepts that are connecting the real world in terms of data coming from these different systems. Now I'd like to show you this other knowledge graph. This is a virtual model. This is bringing together actually all 5 of these knowledge graphs into one place. So I'm going to open this one up, and I'm going to run a simple query here first, just to show you all an example of querying a person. So this is a person. This is actually a customer of this demo data that we have for utility, Mark Brazil. And what you can see here is querying and pulling back different, results out of the knowledge graph. So you can see that Mark Brazil has a telephone number. It's actually a different object in the knowledge graph. Mark Brazil also has an email address, also a different object in the knowledge graph. So you can move your way down the knowledge graph to grab all the things needed, as a result. I'm showing these simple queries because I'm about to show a more complex one, and I'm going to show it in that semantic match form. So again, lots of knowledge graphs, all built into Autonomous Database, on the back end of getting all the data into relational form first. These knowledge graphs are able to allow us to build more complex queries. So I'm going to go over to this person to electric grid one. This is the one I showed a minute ago, where we're actually connecting, a person all the way over to the other side of, how they're served on the grid in terms of a transformer and the substation that is serving them. So I'm going to open this up. Again, in this case, we've created a materialized view out of it because I wanted to materialize this data, make it quick. But the SQL behind this is powerful in the sense that it is able to run a semantic match query, and it's able to pull back those results. So what you're going to see is SQL at the top, you're going to see Sparkle next, and then you're going to see how we're able to flatten that for use on the other side of things. So yep, here we go. So you can see at the top here, this is where we're flattening things. If I look back over here, you can see like the flattened columns here. So as Melly was showing, this is an example of actually using a SQL materialized view, and I'm flattening out this data here. But the source of this is actually coming from a fairly complex Sparkle query. So I showed you a simple Sparkle query a second ago, which was just querying a person. This is going much deeper. This is actually starting with a person, getting their account, lots of details about their service, going all the way into the circuit and transformer, lots of things on the grid. And we can very easily join these things together in terms of meaning to come to complex results that would be very challenging otherwise, and do it across multiple sources. So again, like I was mentioning, there's 5 sources of data coming together in this one knowledge graph. We're able to write one combined query to get this view that we've never been able to get before, and then flatten it back out in this semantic match query for use in this very easy form that you saw here. Okay, so that was a lot of stuff in terms of looking at queries and data and different pieces. Next, what I'd like to go to is show you some of these results and what they look like in Oracle Analytics Cloud. So we've got the data well prepared. It's in relational form. It's also in graph form. We've done these semantic match queries, and that has all prepared different layers of the data so that we can get great results that have been very challenging for this industry otherwise. So I was mentioning that person to electric grid view. This is a result of the other side of that. So what you're seeing first is a bunch of equipment on the grid. So these are transformers. These are the pieces of equipment outside your house that really normalize the voltage as you're being served electricity at your home. And like I was mentioning, the world's getting more complex in terms of how the grid operates. So what we need now is a view that actually brings together data from many sources. So I was mentioning those electric vehicle charging locations. You can see those here. They're in red. So this is bringing in data from the Department of Energy, overlaying it with data from the grid system that I was mentioning that has like these different circuit IDs. And the key view to get to here is this stuff in purple. So these are all data coming from different sources that show solar arrays, wind turbines, different detected electric vehicles. So getting that view of, all right, what are the different distributed energy devices being adopted on the grid here in purple? How are they affecting one particular circuit? In this case, it's circuit 2433. And ultimately, how are these red dots being deployed as well on the grid? And getting a better view of all this to do better grid planning. So again, bring in data from 4 or 5 different sources, bring it all together in a knowledge graph, and being able to get to results quickly in something like Oracle Analytics Cloud is what we're showing here. I'd like to go into a little more depth too on some of that language output. So I mentioned, I showed the ontology briefly. On the left here is a more detailed output of in language form of that ontology. So producing a language-like output from the ontology from Autonomous Database, which is powerful in terms of giving great data to large language models as an example, because that's a huge thing right now, prepping data for generative AI. And also on the right-hand side is the actual output of the real instance data from utilities. So this is knowledge graph output. And I'll grab a few different examples just to show similar things what we were looking at a second ago. So I'll grab those electric vehicle charging locations. You can see here all, I think there's about 70,000 different charging locations in the US that are all spit out here in language like output. And this is great because it can be used for retrieval augmented generation of LLMs, as well as other great things that are emerging in the semantic and linguistic space with generative AI. I'll show a few more examples of this. So let's see, let me get rid of that one. And I'll grab person real quick because we looked at that one. I'll show one more. Maybe I'll show a utility bill just as an example. So again, producing language output for all of these different things is possible because we've prepped all that data in a knowledge graph with the ontology and autonomous database. And lastly, I mentioned that we are bringing in different public data sets.
Sorry, Jason.
Yeah.
If you just go back for a second, one
Sure.
thing I wanted to add over there was, it's not just that you're generating natural language output, you're also generating additional context, which the knowledge graph is adding. Like, what is the energy unit? What is the currency?
Absolutely.
Location is a US postcode, etc.
The construction of this language would only be possible because the ontology is actually doing the nouns and verbs, the industry, like you said. Yeah. And then this is just a view I like to show it because it's fun to show, of bringing all those different EV charging locations in. Again, we've got electric vehicle models coming in, census data, weather data, lots of different things through this industry data exchange. But again, like getting that blown up view of, all right, where are the hot spots of EV charging locations that are going in, especially in super heavily traveled areas, and how do grid operators better plan for where broader adoption is coming. All of this is being fed again from the knowledge graph and autonomous database. All right. That was most of what I had to cover. And I'll stop there and we'll see what questions we want to cover.
There was a question. There were actually two questions, which hopefully you can address. One was about, what is the standardization stage? I'm going to assume that this wasn't about standardizing geocoded addresses, but about standardizing terminology. So if you can expand on that a little bit.
Yeah, so if the question is about how we built this ontology, I'll try to answer it in a couple of different ways. It's about how we built the ontology. We actually have been using a lot of standard tools to manage the ontology, like Protege or other tools. But the main reason we're able to standardize terms here is actually working with the hundreds of clients we have in the energy and water space, working with them to work through, should it be called a feeder or a circuit? Why should it be called that? What's more specific? It does take time to work through those, but getting to those answers, is easy then to inject into this ontology and autonomous database. We are exploring coming to those answers off of LLMs as well, but that's more future stuff. If
right.
the question,
so the question actually is related to that, I think. And then, so the next thing was, once you've done that standardization, how is it actually used? In this case, you guys are constructing a custom ontology. That's
correct. Yep. So I'll go, let me.
Right, and that's what's being used, and the ontology is managed in the database and stored in the database.
Yep.
And used from there. Sorry, there was another question related to the ontology. Now, this is a custom one based on public ones. The question was, can somebody else get access to your ontology, or is that proprietary?
So the ontology will be baked into this service when it's launched. So you'll be able to use every bit of the ontology in the industry data exchange when it's launched. And again, in some cases, it is connecting into other more public ontologies that are out there. But the ontology will be baked into this service when it's launched. And again, yeah, it has been really prepping it, with our industry partners and different customers. That is how we got here.
Thanks. And then, since we do have a bit of time, can you expand a little bit on how you'll actually use the natural language that's generated? What all can you get the LLM to do? now that you've generated the natural language?
Yep. So the expectation there, we're starting pilots on this right now, is to leverage the language output, vectorize it, and then use that vectorization to feed RAG, like retrieval augmented generation, which is a kind of emerging capability for generative AI, where you can actually inject data from other sources other than what the LLM was trained on. I actually have a different slide on that I can pull up for 1 second. Yeah, so within OCI there is the Gen AI service, so there is a new RAG agent for that. That RAG agent is intended to connect to your company's knowledge bases, ask a natural language question. So we're focusing on supplementing that with the language output from this industry data exchange. And the reason that's powerful is really, to focus on, mitigating hallucinations, bring data to the point that it really has incorporated your domain or industry, enterprise data. So does that make sense?
Yeah, thanks.
Cool.
Excellent.
I think that's a very hot topic of research. If folks are looking at how can knowledge graphs help address hallucinations by, like Jason, like you said, by capturing the fact that this is curated data that an expert can provide.
That's right. Yep.
Okay, excellent. So thank you very much, Jason, and thank you, Melly. That was great. Guys, the Q&A is still open. So if you guys want to type your questions, I see more questions coming. So Melly, your question was whether there was a live labs. I see Giant. Do you want to answer that?
Yeah,
You're typing it,
yeah,
right?
I'm answering it, but I think I can just answer it live. So there is a live lab, a section of a live lab for Oracle Graph that includes what are ontologies, how to use that as part of Autonomous Database and Graph Studio. And what is work in progress is something similar to what, a simpler version of what Jason is showing here, right? Which is, how do I use this in data integration, harmonization, etc. So that is work in progress. And I was trying to find the link to the live lab. Once I find it, I'll post it. The one which has the explanation of ontologies, etc.
Excellent. All right. Yeah, and worst case scenario, I'm going to make sure that it's part of the recording, right? So include the links there as well. So again, thank you very much, everyone, for joining today. Again, the Q&A is still open. So if you guys have questions, make sure to type them in there. Okay. So just wanted to make sure you guys know, again, the important links are here, right? If you guys want to join us in there, please feel free, right? I'm going to, again, share the links, in the chat for Zoom, right? Again, thank you for joining, guys. It's a great session. Thank you, Jason, and thank you, Melly. It was great. All right, guys. So basically, final thoughts. Then I see another question. It's open there. So team Melly, Giant, and Jason, if you guys can answer that one. I will, in the meantime, just mention that we do have the recording. So the recordings of this session and the previous sessions are going to be always in the same link that you see on top here, the ADB Learning Lounge. That's the main page for Ask Tom. And basically, well, that's it. So keep an eye on the next sessions. I'll send a survey. You guys take a look on your inbox emails. I sent a survey for topics. So I'll send it again to you guys can vote on your favorite topics for upcoming, sessions, right? Future sessions.